Hello and welcome everyone. I am Shivani Garg, Assistant Professor from IIMT University, Meerut. Today I am here to give you a lecture on control system, and in next few classes we will be studying the control system, in which we are going to study the transfer functions, block diagram representation of a control system, time and frequency response analysis of the system, and state space analysis. So before starting these lectures, I would like to tell you that you should have the basic knowledge of differential equations, Laplace transform, signal and systems, and so I would like to request you all to please go through with these topics and then start this subject. So let's start today's lecture. So in today's lecture we will be studying the introduction to system and control. So first thing is, what is systems? So system is basically a combination of components which gives you a desired output from any form of input. So this is the block diagram shown here. You have a system, you give any kind of input or excitation to it, and then you get a desired output response. It can be a collection of multiple subsystems. So you have different systems here, multiple systems, these are called subsystems, and you give another input and you get output. Example of system, there are so many examples of system. The best example is human body. We are as a system only, we give it some input in the form of, suppose in the form of food, and we get some output in the form of energy. So this is basically the example of any kind of system. So this particular system has 4 subsystems, 1, 2, this is first, second, third and fourth. These 4 subsystems making a combined system which gives you a desired output. So these are the examples of system in the real life. First one is motor, where input is the electrical energy and in output you get the mechanical energy. Another example is air conditioner, where input you give the desired temperature. Another example is air conditioner, where as an input you give the electrical energy in voltage and get a output heater energy in the exchange. And another example, as I have told you, is the human body infected with a virus. Input could be a drug administration, and output is the drug distribution and effects on the body. Another example of control system is a vehicle, that could be a car, bus or bike or cycle. In this, input is the acceleration or deceleration and output is the vehicle displacement. So this is the main classification of systems. There are multiple types of classification in the control system. One is linear and non-linear system. Another is, so one is linear and non-linear system, where another is static and dynamic system, then time invariant and time varying system, and then causal and non-causal system. We will be studying these in detail one by one. So first is linear and non-linear system. Linear system is where output system varies linearly with respect to the input. So this could be seen, the example is I is equal to V by R or X is equal to My. Okay, where input is Y and output is X, and then the output varies linearly with respect to the input. Another example is non-linear system, where output varies non-linearly. The example of this the non-linear system is diode. So next is static and dynamic system. In static system, at any time output of the system depends only on the present input or memory, where static system memory is not there. So any system which depends on the present input only. So Y is equal to X of t. It does not depend on past value or future value. It depends on the instantaneous value only. So this is called the static system. Another is dynamic system. In dynamic system, where you have memory, it depends on the past or future system, so it is called the dynamic system. The example of static system is resistor, where I of t is equal to V of t by R, and for example of dynamic system is IT is equal to 1 by L integration of Vt integration dt. Another Classification of system is time variant and time invariant. As the name suggests, time variant system are those which varies with the time. The output varies with the time with respect to input. The example of the time varying system is this aircraft mass of where the output varies with respect to the time. And time invariant systems are those where the output does not vary with time. The example of this is an ideal resistor, because the current is fixed depending upon the R, and the value of V, it does not depend on time. Next are the causal and non-causal system. Causal systems are those which depends on the present and past value but does not depend upon the future value. These are called the causal system, and the example of causal systems are thermostat based AC or motor generator. They do not depend upon the future values. And non-causal systems are those which depends upon the future value. T plus 1 shows that it depends upon the present time and time in future time also. So the example of non-causal systems are weather forecasting system and missile guidance system. So missile guidance system is depending upon the future output. So this is the non-causal system. What is a control system? So till now we have studied the systems. There are so many systems, but what makes a system a control system? So a system or mechanism which directs the input to another system and regulates their output. If we require a desired output, then we need to control a system's input with respect to output, so we get the desired output. So this is called mainly the control system. Control system alters the response of the plant or system as desired. So this is the example of open loop control system, where we do not compare the output with the input. Here we have a desired reference input, we require some output, we have some desired reference input, and then we have a controller to control the output, and then this gives a control input to the plant or system, and then we get the desired output. Okay, so in the normal system we have simply this plant or system, we have input and then we get output, but in control system we need to have a desired output. We want to have a fixed output, so we give a reference input, we have a controller, we give this reference input to a controller, we get some controlled input and then we give it to some system, and then we get the desired output. So this is called the control system. Disturbance, so there could be some disturbance which hinders that we get in getting the desired output. So what we have, what are the disturbances? Unwanted signal which affects the output of the system is called the disturbance, and because of this only we do not get the desired output. So we need to have a controller, this system to be controlled to reduce the effect of disturbance. So what we do? We need to have a control in the system. So we have a feedback control system. Here we have we control the input with the desired output reference. We give a reference, here we have desired reference input, then we give it to the controller and we got the control input, and then we give it to the plant or system and then we get the output. This is the same as in the previous slide. We have a disturbance. Now to remove this disturbance, what we do is we compare this output with our desired reference input, so that we can this controller give a desired output, and this controlled input can be given to this system to reduce the effect of disturbance. So this is called a feedback control system. So for this lecture, this is it. In the next lecture we will be studying the modeling of the system. Thank you so much.